page 515, number 13, where we look at a problem like this. Page 515, number 13, taking the antiderivative of x squared plus 12x plus 12 divided by, over x to the third minus 4x dx. All right, taking the antiderivative of that. I hope we have time where I can talk about how, Mr. Hendricks, how do you know whether to use a calculus semester 1 technique versus a calc 2 technique? How do you know whether to use integration by parts, what we did earlier, versus this new technique, partial fractions? I'll try to talk about that. Hopefully we have time before we leave, before the show ends. All right, so what we talked about here is to factor out that bottom, factor out the denominator. That's one tip right there. If you can't factor that bottom out, you probably don't want to use this technique. All right, so we have x squared plus 12x plus 12. If you can't factor that bottom, you probably don't want to use this technique. All right, so if you factor that bottom, you end up with x times x squared minus 4. All right, so you just factor that denominator out. You can factor this out even more. You can factor this out even more. You'd end up with the antiderivative of x squared plus 12x plus 12 over x times x plus 2 times x minus 2, all right, dx, all right? So now what you're going to do is you're going to rewrite that. Okay, so you're going to rewrite this. All right, so you're going to rewrite this to be this is very difficult to take the antiderivative of, but we're going to try to turn this into something that we can take the antiderivative of. All right, so we have a over x plus b over x plus 2 plus c over x minus 2. All right, if we can substitute in for a, b, and c, it's going to be much easier to take the antiderivative of these three fractions versus this one big one. All right, so let's try to do that. Let's multiply all of this. Let's multiply all of this by the least common denominator of x times x minus 2 times x plus 2. All right, so if we multiply all of this, x times x minus 2 times x plus 2 times this, we'd end up with this numerator, x squared plus 12x plus 12, all right, plus 12, is equal to, if we multiply this times the x, you would end up with a times x plus x minus 2 times x plus 2. All right, and then if you were to multiply this times this fraction, you'd end up with plus b times x minus 2. All right, because the x plus 2's would cancel. And then you have plus, if you multiply this times this fraction, the x minus 2's would cancel. You'd end up with c times x times x plus 2. All right, now you're going to try to solve for a, b, and c. And this is going to be a mouthful, but let's see if we can finish it before the end of the show. All right, so let's substitute in a, or let's substitute in x to be, let's try substituting x to be 2. Make x 2. All right, so if you make x 2, you end up putting a 2 here. So you end up with, put a 2 here, you end up with 4 plus 24 plus 12 is equal to, we substitute in 2. If you put a 2 here, all of this would cancel out. That's why we chose 2. That's why we chose 2. If you were to put a 2 here, all of this would cancel out. All this would go away. And then you'd put a 2 here, you'd end up with, you put a 2 here, you'd end up with 2c times 4. And you'd end up with, that's 16 plus 24. 16 plus 24. Notice how we, just making sure. You get 40. You get 40 is equal to 8c. 4 is equal to 8c. C is 5. C is 5. Okay? So now you got the first number. That's 5. Let's substitute in x to be -2. You'll see why in a minute, why I'm choosing -2. All right, so now let's substitute in -2. If you put in a -2 here, you end up with 4 minus 24 plus 12, all right, is equal to, let's put in -2. If you put in a -2 here, that will go away. If you put in a -2 over here, that would go away. But let's put in a -2 right there. You put in a -2b times -4. All right, because a -2 there would get -4, and you get -20 plus 12 would be a -8 is equal to 8b. So b is -1. B is -1. So now you know C is 5, B is -1. The only thing you'd need to know now is A. Man, I wish we had more time. All right, so the only thing you need to know now is what is A. All right, so what you could do now is, let's say we wanted to put in x is 0. Let's try x is 0. All right, so you could put in 0. Man, I wish we had more time. So you put in 0, you put 0 here, 0 here, you'd get 12 is equal to, you could put 0 here and here, you put 0 here and here, you'd get -4a, -4 times a, and a, we don't know what that is. Then you have plus, if you put 0 here, everything here would be 0. If you put 0 here, everything here would be 0. Okay? All right? So now what you could do here is see that A, you could see that A is -3. A is -3. So you have A, B, and C. All right, so now you do all that to go back up to your problem, which is up here. So A is -3. So you really want the antiderivative of -3 over x, -3 over x. B, you have minus 1 over x plus 2. All right, we got 1 minute left. X plus 2 plus 5 over x minus 2. Final answer, this is not too bad to take the antiderivative of. Antiderivative, you get -3 natural log x minus natural log x plus 2 plus 5 natural log x minus 2. Sorry we had to rush through that.